Before we get started, guys, just a quick question. How many of you in the audience, and I'm asking for a show of hands, please don't be shy, have either built product as part of a product management team, a product development team, or a product engineering team? Just a quick show of hands. Oh, that's a lot of you. Well, I mean, we are in Bangalore, so I guess that makes sense. Okay, good. More towards you later. So typically, when you build product, there's a three-way dilemma, which people sometimes call a trilemma, that you have, right? And we'll get to what those issues are in a little bit. So how many of you, again, quick show of hands, are familiar with this process as part of product development, right? You need to be able to, first you gather your requirements, do a design, throw that design in the dustbin, do fresh requirement gathering, design again, develop multiple changes in the development cycle, and then you're testing QA. Finally, you ship a product to market, which is, hopefully aligned as part of a product market fitment. Just again, quick show of hands. How many people working in AI in some way, shape, or form today? Wow. Okay, great crowd. Now, do you guys think that this is the typical product cycle for AI? How many of you think so? Nobody? You guys are doing my job for me. You're right, it isn't. This is not the normal product cycle for developing AI products. This is, right? How many of you are familiar with this process right now as part of a typical AI product life cycle in terms of model building, model experimentation, taking models all the way from building, prototyping, experimentation, all the way up to inference? How many of you are doing some part of this for your organizations or in your individual capacities today? Again, right? So typically, as with AI, as you can imagine, everything begins with data. Garbage in, garbage out, right? So data collection is important. Make sure that your data sources are the right sources. Clean that data, frame that data, normalize that data, abstract that data, bring it into a model lake, build your data pipelines, right? Then you begin with your model building and your model experimentation. Train the models on that data. Yes, I see a lot of people nodding, so clearly you all are relating to this. Then you do your fine-tuning on top of that. I assume you may have done some pre-training, post-training, and then you finally bring this into inference, hopefully. Correct? How many of you have done this, gone through some or this entire part of what I've just explained? A lot. How many of you, okay, everybody put their hands up. Can I just request you to keep your hand up for a moment? Okay. How many of you thought that this was easy? One very brave and obviously very intelligent lady in the front row over here. Okay, it isn't easy. And the reason it isn't easy is you're faced, all product engineers, all data scientists, all ML engineers, and all ML ops engineers, the last three of which are very often the same person in an organization, are faced with a three-pronged trilemma, if that's what you want to call it, right? The problem is you need to be able to build your product, your AI product, at the right unit economics, with speed to market, right? And build it in a way that has got that product market fitment and is now scaling with user trust. Yes? This is regardless of what kind of product you've built, whether you built an AI model that you want to take into inference or whether you built a car. We all agree with this statement? Great. Now, the problem is, this is, in the field of AI, fundamentally challenging. Most people who are successful in taking their AI products to market, at best, have met two of these three criteria, right? Side note, a friend of mine recently bought an apartment, moved from a 2 BHK into a 3 BHK, and was getting very, very frustrated till his broker sat him down and said, "Sir, you can get the apartment that you want, the area that you want, and the budget that you want. Pick any two. It's not possible to get all three," right? So similarly, you can build product at the right cost with the right margins, perhaps with the right speed to market, but maybe not really aligned to what the market needs, or any two of those other criteria. So let's now talk about that in the field of AI. How many of you, again, quick show of hands, this is going to be a trend during my talk, by the way, have built AI, either done model building, model experimentation, or inferenced on AWS, either EC2 or SageMaker or Bedrock, or on Google Cloud, or on Azure Cloud or Azure AI Studio? Quick show of hands. Big number. How many of you worked for an organization that then took that into production? Again, how did those costs work out for you guys? I'm assuming not well, right? Just to give you a little bit of a, how many of you are familiar with what an H100 GPU is? An NVIDIA H100 GPU? Okay, a fair number. AWS, for example, would charge you 4 times what the prevalent Neo Cloud market rate is for an H100 GPU. So what they will give you is the speed and the ability to build a good product and ship it to market quickly and scale, but you haven't met the unit economics, right? Now, let's assume you decide to go the other way. Let's assume you decide, okay, I've burnt my fingers, I've consumed my cloud credits on AWS or GCP or Azure or whatever it is, and now in scale, we're burning through cash to take this model into production and to be able to, offer it at scale. So forget it, let's get out of that, we'll pivot completely in the opposite direction, and what we're going to do is buy a bunch of GPUs and put it in-house, right? Or put it as co-location in someone's data center. Quick show of hands for people whose organizations may have done that. A few, and that's actually what I expected, is because the capital costs of GPUs are high, right? Most people prefer to use GPUs in a cloud environment so that they don't have to spend hundreds of thousands of dollars or millions of dollars buying the GPUs, but there are a few who do, especially large organizations. Now, they're in control of their unit economics, but where they've compromised is speed and scale both. Because some of the biggest organizations that we talk to aren't able to actually present or offer the infrastructure that they've bought to their lines of business for the use case that they're looking for, and to have it scale as the business grows without significant bottlenecks, right? So the on-prem, the CapEx approach to being able to provision your infrastructure and to be able to build your AI completely in-house, you've met one of the two criteria. So you've kind of moved backwards a little bit. The third option is, of course, being able to scale and build user trust, right? So that, again, is challenging. How do you maintain your unit economics, get speed to market, and build user trust? This is a very, very sticky problem that us as product managers tend to face on a day-to-day basis, right? Now, luckily, in the field of AI, especially when it comes to offering AI cloud platforms that allow model building, fine-tuning, and experimentation, there is an option. And at Neysa, we call it Velocis. Velocis is, and it took us a while to come up with a definition for it, an end-to-end AI cloud platform that allows you to meet your AI initiatives, to fulfill your AI objectives across training, fine-tuning, and inferencing at scale, completely on demand, with the correct unit economics. Bit of a mouthful, I know, but what it is a sovereign AI cloud, but we don't stop just at the infrastructure as a layer. The Velocis cloud is not, here's a GPU, now go have fun with it, do what you want. You can do that if you so choose, but at the end of the day, the problem when it comes for us as AI builders, as product creators, as data scientists, as MLOps engineers, as ML engineers, or as product managers, the problem isn't just the access to the GPU on demand at the right price. The problem is, how do you help me with the right tools, frameworks, libraries, and pipelines to be able to do all of that completely on demand with a click? Do you give me a PaaS platform sitting on top of the infrastructure, natively integrated into the GPUs, the storage, and the compute? Yes, absolutely, right? Do you give me, say, how many people experimented with Jupyter notebooks? Wow, okay. How many people are managing LLMs or any other GenAI models in production for inference? Again, a lot. So the ability to be able to click to create a Jupyter notebook, have it run on the correct compute environment, CPUs, GPUs, what have you, do your model building, do your experimentation, and then push that into production. Let's assume you've done it on an open weights model, and now your organization says, okay, great, we've built this conversational user interface, we've built a knowledge extraction tool, we've built this application for decision intelligence. You want to be able to not just have access to a GPU, you want all of the tools sitting on top of that to be able to take all of those use cases into production very, very quickly. At Neysa, we built the Velocis AI Cloud to be able to cater to exactly that. So it is a full-stack acceleration cloud system, purpose-built to meet and scale and deliver your AI workloads across training, fine-tuning, and inference. So in a nutshell, this is what it is. So your bottom layer over there is your infrastructure, right? Can't have AI without the GPUs, the high-performance network, the high-performance storage, everything that you need over there, all front-ended by a very, very powerful orchestration layer, right? So, but let's assume that the infrastructure is a given right now, table stakes. What you need above that is that entire platform that caters to the data scientist, the ML engineer, and the MLOps engineer, right? These are the guys, these are the probably unsung heroes in any organization that are doing all of the hard work in terms of building an AI or meeting the organization's AI objectives, right? So if you want to be able to natively integrate into any of the most commonly used open source frameworks, tools, libraries, PyTorch, TensorFlow, Keras, Theanos, scikit-learn. You want to be able to fetch models with a single click, say, from Hugging Face. You want to be able to do your model building and experimentation in Jupyter. All of that is just click to create. But at the same time, it's very, very natively integrated into the hardware, but with complete transparency. So everything isn't an API call. Funny story, one of the clients that we're working with, medium to large enterprise in the manufacturing space. They paint. So they wanted to take an internal use case into production about 6 months ago. Simple use case, internal knowledge repository for all of the documents and all of the knowledge sitting within their organization, which, as most of us will know, finding the right information within your organization's SharePoint is probably one of the toughest things in the world, right? So they wanted to be able to create a simple chat interface. I'm looking for a spec sheet or a data sheet on XYZ product and any and all literature surrounding that. Seems like an easy enough use case to be able to deploy. You're going to probably have something like Llama Index, LangChain, fetch a bunch of PDFs, extract it from there, sitting with an LLM to be able to serve the responses. Sound about right? Yeah? So they were on AWS. So they call AWS into the room. AWS comes with a partner. They sat down with their AI practitioners. How long do you think it's going to take this model into production? about 3 months of model building and experimentation. You can do it on SageMaker. Okay, fantastic. How much do you think our budget should be? They said, sir, about $4,000 to $5,000 per month for the model building and experimentation phase, so why don't you benchmark about $12,000 for the quarter? You probably won't even spend that. So they turn it on, he turns on Bedrock, beg your pardon, SageMaker, hands it over to his team. 36 hours later, checks his AWS dashboard. How much do you think he'd spent? Any guesses? Not that much, because that guy would have then been fired. But they had spent their entire quarter's budget in 36 hours. They had spent $12,000 in 36 hours. So now, obviously, everyone's running around in a blind panic. How did you spend so much? The CFO is screaming. The CIO is screaming. The data scientist is sobbing uncontrollably in a corner somewhere. How did you do this? Can you show us what does the dashboard say? Where did this get used? We don't know. Everything is just a bunch of API calls, right? It's going to take us at least a week to decipher what these API calls were. What services got spun up in the back end? Were they GPUs? Were they VMs? Was it EBS? Was it ELB? Was it S3? Was it Route 53? We don't know. Everything just seems like a bunch of API calls. We need to go figure this out. So that's the problem. Now, when you want to turn on things like Jupyter Notebooks and take models into inference and have native calls to Hugging Face, it's great that you're able to do that. But you have to be able to do that with very clear and visible costs. If everything is going to be an API call that your teams are sitting at the end of the month for 3 days to try to figure out exactly what those API calls were for, that's not really going to work in an enterprise environment, is it? Because then there's no predictability in the cost. And we all know what enterprise finance teams and CFOs and budgets are like. So what you need is a system where when you create a Jupyter notebook, clearly says that Jupyter notebook is going to sit on X particular CPU or K8s cluster or compute virtual machine or a GPU virtual machine, and this is what it's going to cost you. You want to take Llama 3.370B into production. You want to put it on a dedicated GPU and have it as a dedicated inference endpoint for your organization where you don't want any sticker shock for your inference costs at the end of the month. Here's what it's going to cost you, and that's going to be a flat monthly fee. Please infer it until the cows come home, right? Infer it for anything you want. Ask it how to make soup, and don't worry about what your token usage is. So typically what enterprises need to be able to do all of those use cases that you see on the top of there, model building, model experimentation, is you need the infrastructure, you need the platform, but you need it delivered to you in a very, very granularly visible and a granularly controllable way. So you don't get even a rupees or a dollar's worth of sticker shock when the invoice comes due, right? And that is what Velocis gives you. So coming back to the question that we had, right? You can scale, you can create for unit economics, you can create for time to market, or you can create for scale and trust, right? Velocis will allow you to do all three. So please come to the booth that we've got on the expo floor. We'd love to be able to talk to you in terms of how we do this, how we've deployed use cases for some of the most well-known names in the country, guys who are building model gardens for their organization, people who are building very, very interesting GenAI use cases for their organizations. We do a lot of work for manufacturing. We do a lot of work for fintech and financial services, healthcare, education, ISVs, AI native developers. So we'd love to be able to share some of those use cases with you and see if there's any way we can help you achieve the same objectives. Yeah, that's kind of, I'm at the bottom of my session, but this is just a quick run through of what the Velocis portal looks like and how you can spin up infrastructure really, really quickly. We can show you a much more detailed version of this demo at the booth. It would be our pleasure to be able to do that. So yes, please get in touch. These are some of the use cases that we're currently delivering on the cloud today. So you can see everything from foundational model training and frontier model development, all the way across that spectrum from training on the left to inference on the right. And this is just a sample of the use cases that we're able to help our clients meet today. So please come over. We'd love to chat. We'd love to see how we can work with you and if we can help meet your AI objectives. Yep, that's it. Also, very quickly, for startups in the room, we do have a startup acceleration and credit program. So please come visit the booth and see. We'll help you determine if you're eligible to consume startup credits on the Neysa Velocis Cloud. Have I covered everything that I needed to? Excellent. All right. Thank you very much, guys. Yep.